not coming in YouTube? YouTube, no. Is it not? You have always given this one. I don't have to do anything for the YouTube, no? Whatever team you are doing that way. What to do that now? Because YouTube, I have not done anything to YouTube. And YouTube is that but in team it is coming. Yeah. All these things I have explained. Voice is coming. Well, here what was, but will it come from the beginning? It will come. Acha, okay. Acha, now it is fine. So should I? Acha, so I need not repeat that thing. Na? I should go ahead. Acha, okay, fine. Okay. So what I am telling that this is chip velocity given shear angle to thermal number is calculated. Acha, this is empirical type of formula. Okay, let us see that. Okay, you tell me that. Okay, let me just show that from last year's assignment. I will tell because this already you have distributed, and I should go to last year's one. Up to which section you have distributed? Of which assignment you have distributed?
Solution up to 5 and
देखो
assignment 8.
चलो बोलो कौन है?
पूरा assignment upload हो गया questions.
You tell me.
ओ सर थोड़ा दीजिए.
कौन है?
कल्याण.
हाँ? कल्याण मैं कह दूं कि क्लास चल रही है अभी.
क्लास हो रही है.
Okay. 20251 ना 2024. Assignment 5. This one. Assignment 6 I will be given.
Yes. Assignment 6. Yes.
Okay.
Solution also has been uploaded for assignment 6.
Acha, this I can close that, na? Or this one. I think I have to mute it. Huh?
Yes.
Right click. Where is mute side? Mute side, na?
Yes.
Okay, fine. Yes. So let us go to that. Where is assignment 6, na?
Yes. Assignment 6.
Yeah. So mild steel bar of 50 mm diameter is being turned using a tool with signature 5127 1015.04 as per ASA system. Feed rate and depth of cut during turning are 0.3 mm per revolution and 0.5 mm per respectively. Many people, in fact, here also, it is not appropriate to use that feed rate actually. It should be feed. Because generally, although it is this one, because generally when we say feed, this means that we are talking in millimeter per revolution. But if we take feed rate, generally it becomes millimeter per minute. Okay. So correct word should be feed actually. Rate we use feed and depth of cut during turning are 0.3 mm per revolution and 0.5 mm per respectively. Okay. So feed is 0.3 mm per revolution. That means chip thickness, uncut chip thickness will become 0.3 generally. Okay, if we have this thing that is provided side cutting edge angle is 0. That means in any way uncut chip thickness is proportional to feed. So undefined chip thickness in mm and chip width in mm are respectively. So these are the questions. Okay. So suppose it has been given. So side cutting edge angle is 15 degree. First you have to, student has to do what? That you know it is a tool signature. It has got 7 elements. So first is that top rack, then side rack, then end cutting edge angle, this one, end relief, then side relief, then end cutting edge angle and side cutting edge angle, and then nose radius. Okay, because you know you have to remember this thing that what is the sequence. Generally, this question is asked in different systems. There is a different type of this one. Suppose you have got ASA system. In ASA system, first thing will be back rack angle, which is also called top rack angle. Okay, so back rack is 5 degree. Then you have side rack angle. Then you have end flank angle. End flank angle or end relief angle, and this is also called side flank angle or side relief angle, side clearance angle. These are different names. Finally, it is end cutting edge angle 10, no? And side cutting edge angle is 15, and nose radius is 0.4 mm. Okay, now what happens that here side cutting edge angle is equal to gamma s. This is equal to 15 degree. Feed is 0.3 mm per evolution. Okay, depth of cut is 0.5 mm. Undeformed chip thickness. So this will be F times cos gamma s. Okay, so 0.3 into cos 15 degree, that means 0.2898. And undeformed chip width is equal to d divided by cos gamma s, and this will become 0.5, and this is cos 15 degree, that means 0.5176 degree. 0.5176. This is also always one should use unit actually. No? This is very, but anyway, although it is written in mm, but in my final solution I should always put some proper unit final answer. Okay, so this is mm. That is this one. Now another question is that a mild steel ball of 120 mm diameter is turned with a tool. The feed velocity and rotational speed of job are 2 mm per second and 500 rpm respectively. The cutting speed and feed are respectively. How much you have cutting speed? So this is mild steel bar, diameter 120. Feed velocity is 2 mm per second. This is okay. Feed velocity. Rotational speed is 500 rpm. Cutting speed is we see pi dn by 60. That means pi into 120 divided by 500 divided by 1000 into 60. So cutting speed comes out to be 3.142 meter per second. And feed is equal to, because it is 2 mm per second. So per evolution in 1 minute, it will be 60 into this, but RPM is 500. So it becomes 0.24 this one. So that is why the question was that how much is the feed and how much is this one. So yes. Next question is that suppose deviation of a machine surface at 5 points from the mean line over a surface length of 4 mm are this much. The root mean square surface roughness is the deviation of a machine surface at 5 points are given as H1 is equal to 6 micrometer, H2 is equal to 9, H3 is equal to 5, H4 is equal to 8, and H5 is equal to 10. Then the root mean square surface roughness becomes HRMS is equal to under root H1 square, H2 square, H3 square, H4 square, H5 square, and these are the 5 points. So divide by 5 point, it becomes 7.823, this one. So here this comes, there is no use of this data line over a surface length of 4 mm. That is what 7.82, this is this one. Now, during the turning of a mild steel ball of 130 mm diameter, 2 different tools are used. In one tool, nose radius is very small. The side cutting and end cutting edge angles are 20 degree and 10 degree respectively. In the other tool, the nose radius of 0.5 mm is provided. The feed used in both cases is 0.5 mm per evolution. The peak to early height in mm in the generated surface for first and second tool are respectively. So given mild steel bar is 130 mm, side cutting edge angle is given, end cutting edge angle is given, nose radius is 0.5 in one case, that means in one tool, but other case nose radius is basically basically it is very sharp tool. Okay, so that means that this is this one. So feed is 0.5 mm per evolution. So for the first tool, the peak to early height will be h max is equal to f divided by tan gamma x plus cot gamma e, and this will be 0.5 by tan 20 degree plus cot 10 degree. Okay, you can say it is basically degree. Okay, tan 20. This is basically degree. Okay, you can have this one. Okay, it is. This will be degree. Where is that degree symbol? Done. Okay. Our second tool, since if we assume that peak to early height is f square by 8r, so roughly it comes like that. Okay. Then some problems are very simple. If you have empirical relation, you just have to put the data. Assignment 7 also has been done or not done?
But not uploaded solution.
Not okay. But they have submitted.
Yes.
They have submitted.
Submitted, not yet. Maybe not yet. Assignment 7 is going on.
Assignment 7 is going on. So I should not reveal that one because similar type of thing. But assignment 5, okay, assignment 5 is this one. Cutting fruit should have high specific heat, high thermal conductivity, and low volatility. Okay, because it should not be volatile. So some are descriptive type questions. Then you go to okay, even the previous one. Let us say assignment 4 solution. Okay, some of this can be discussed. So let me just see that if there is any question. Two people are watching it. Okay, here, and this is yes. Where is that thing? Yes. Okay. So some people are watching, but I have any question in the chat. Let me see that chat. Chat questions are not. Chat, yes. Chat. In actual, what is that? Somebody has written something. Huh? In actual assignment, the feed rate and depth of cut during turning are this we were solving. Previous assignment, yes. Yeah, we are solving the previous assignment because yes, correct. So the answer is that previous assignment. Okay, because that I don't want to repeat the same thing. What I want to tell that in last year what we did. So some data. So what I am telling, the exam will also, most of the questions can be from assignment also. We will change the data. Okay, that's why I am trying to show you that how this is, and if there is any mistake in any assignment, how you can rectify. Okay, that means I am just pointing out. In actual inclination, yes. So that is what he asked a right question, that in assignment the feed rate and depth of cut very good. Yes, this book is very good. Okay, so this book is, you follow the book of GK Lal. That book is the perfect actually for this purpose. Engineering Science by GK Lal. Okay, so that is correct. Okay, this is correct. In actually feed rate and depth of cut during the and 0.3 mm respectively. Okay, but what I am suggesting you that avoid this habit, although not so critical, but you don't say feed rate, you just say feed is 0.4 mm per evolution. Okay, feed is this one. Even if I have written by some mistake sometime, you say it feed. Okay, feed rate is not the proper word because feed rate is expressed in millimeter per minute. Okay, although many times you may get, some books may write even feed rate also, but what I am trying to tell you, good habit actually. So good habit is to call it feed, and book of that GK Lal is very good. Okay, now I am going to tell you that assignment 4 solution. Okay, let us say it is also of the previous year, I think, or this year. This previous year. Inclination angle 9 degree, normal rake angle 6 degree, So these two things have been given. Then velocity rake angle can be calculated. There is a formula. Velocity rake angle is tan alpha v by tan alpha n by cos I. So velocity rake angle will be same as the normal rake angle in orthogonal machining. So this is based on that. This chapter is a bit difficult, but you can use that formula, you can understand. You have to visualize. In oblique turning, chip thickness ratio is this. Value of normal shear angle is this one. So normal shear rake angle can be found by formula. These are also formula based question, and this was that maximum rake angle, how it is related to back rake and side rake angle is by this formula. Tan alpha m is equal to under root tan square alpha b plus tan square alpha s to the power 0.5. And these are the formula for inclination angle. Okay. And then this is also given effective rake angle formula. This is based on the formula only. And this is about gauge length, etc. That you know that this one sensitivity, I think we have covered, and there must not be any doubt in that. Okay. Therefore, doubtful other cases, I just want to tell it is 24, not 24 question paper. Okay. Even I can show you last year question paper so that you can get idea. Last year we had a pattern maybe more or less same. We have 10 recall type question, just memory based. Okay. In the tensile test of which material the distinct upper and lower yield points are obtained. Question answer is mild steel. In the broaching operation, broaching machine, many people have not seen any broaching machine. Lathe and milling machines are very common, but broaching machines are not found everywhere. Broaching can do the machining at one traverse of the broach. So here several cutting edges are involved. In the top view of a single point cutting tool, following elements are visible: end cutting edge angle, side cutting edge angle, nose radius. Okay. The yield shear strength of a work material is 150 MPa. Not the yield strength, but yield shear strength. And the factor between the work and tool material is 0.3. Then limiting frictional stress between the tool and the workpiece is 0.3 into 150. Okay, that means 45 MPa, correct? 150 into this one. The angle between a slip line and free surface is 45 degree. This is also recall type because slip line is the maximum shear line, and maximum shear stress is 45 degree to principal stress. And if one free surface means this is a principal stress because there the stress is 0. Okay. Then cutting forces are measured using which instrument? Everybody should know that it is dynamometer. It cannot be tachometer. Tachometer measures the velocity, okay, every speed. RPM it can measure. Encoder, that is also you can measure the position. Pyrometer, you can measure the this one, temperature. If the average wear particle size in attrition is X and in galling it is Y, galling it is Y, then X is smaller than Y. That means galling removes the large amount of material, okay. In a straight turning operation, undeformed chip thickness is 0.06 mm. If the heat is doubled, the undeformed chip thickness will become how much? Many people think that depth of cut is related to chip thickness, but it is not depth of cut, it is basically feet. Okay, that is why I have given this question. Okay, for grinding of low carbon steel, the most widely used abrasive among the following abrasives is. Now you have to do steel. Steel silicon carbide is not that good. Carbon also, there is also carbon here also, but most widely we use aluminum oxide. Aluminum oxide is better suited for this one. But if you want to cut the aluminum, then maybe you can use silicon carbide. In a CNC lathe, the Z axis is always along the spindle axis. Okay, that is our convention. So we should know those type of things. So this is how to remind formula, as there are many formula, push and pull type of broachage. Yes, okay. Very good question that he asked, that push and pull type of broachage. Okay, first I'll do Okay, I am telling that. Okay, everything. So push and pull type of broach is what? That in one I will push the broach, okay, from top, okay, and in one the broach will be pulled from the other side. Cylinder will pull it, okay. So if broach length is very high, then the push type of broach can cause buckling actually, and buckling is not very good actually. No, buckling means it's very lengthy one. In pull type one, buckling problem is not there, okay. But sometimes the push type thing is very convenient. Suppose you have to make a blind hole, then push type is okay because from top you can push, okay. Now question is that how to remember that formula. You have said that really formula is only in the tool. Some formula is there that is mostly in the tool conversion, okay. That you know, basically there will be two main formula. One is the inclination relation and other is that one, okay. You can make diagram, and then in merchant circuit diagram, if you can make merchant circuit diagram, you can do very effective way. And you should know, say suppose there is a zero rake angle case, then you can know that okay, many things will go and you can find out. So many times you can try to derive the formula on the spot, and you just do that type of thing. Now for gate, so gate paper solution, which book to refer to for solving production problems? Okay, I am telling the GK Ral's book is very good. That GK Ral's book has given even a lot of exercises problem at the end also, okay. And there will be some conceptual thing. Even Ghosh and Malik book also you can refer. You can solve that this one, and then whatever assignments we are giving, that those assignments can be in somewhat varied way it will come. So it is not RA is roughly 1/4 of this one. If you assume that there is a triangular profile, then it is 1/4 of this one RP. So that means F square by 32R. Approximately it is like that. So here many type of this one conversion type of thing is actually I have covered this, but in gate conversion questions may not come actually. That you know, changing tool angle from one system to other system, but in that may not come this one, okay. Maybe in a specific production time, if somebody can set, that is different thing, but usually I have not seen recently. But the questions will be only on merchant force diagram, and there will be something about surface roughness. So these two things are very important, okay. And although milling also has been covered, but milling type of, so that much type of formula doesn't come, but concept based. So concept based thing is like this also, that if I say many times in the gate, since they test the concept, not the memory, so the questions may be like this also, that suppose they say cutting force is this much, say 300 Newton, and thrust force is 200 Newton. So tell me that what will be the coefficient of friction of the chip on this one surface, okay. कह दो 20 मिनट बाद आओ 20 मिनट. So what happens that it is basically this one chip and this one, okay. So what we can do that now the concept is there. On the chip, your thrust force becomes the tangential force because tool is perpendicular, and the cutting force becomes the normal force. So cutting force is 300. That means normal force is 300 and tangential force is 200. So 200 divided by 300. So that becomes 0.6. So that means based on that, F by R, okay. So it is like that. So cutting force simply by F by, okay, R means if you say thrust force, R otherwise we say FC by FT, okay. FC by, so FT by FC, okay, FT by FC. So it will become 0.66. So these type of things are there, some tips are there, and the basics. So let me just show some more questions that what I mean to say in the gate also. There may be conceptual questions. This question, say for example, not only from machining, but in material science, this question can come. In a uniaxial compression test, the engineering strain is 0.1. The 2 strain will be how much? So there is a relation between 2 strain and cutting strain. This one, engineering strain. Okay, epsilon is equal to ln 1 plus e, that type of formula. Other thing is there also this topic, it comes in the machining also, it comes in the design also. An isotropic material is subjected to a balanced biaxial test, tensile test. I have given sigma 1 is equal to sigma 2 and sigma 3 is equal to 0. The yield strength of the material is 150 as per 1 Mises criteria. So 1 Mises criteria is common. It can be set as a design question also, because in design we use 2 criteria, one for ductile materials, 1 Mises and Tresca. Of course, Tresca is very conservative. We generally use Tresca only 1 Mises, but sometimes in design also based on 1 Mises also you can design. It can be part of strength of material also, and it can be part of machining also. So yielding starts when sigma 1 is equal to sigma 2 is equal to, they are asking when yielding will start. So idea is that if you want to do as per 1 Mises criteria, and you want to know that yield strength of the material is this, there is a formula, sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 1 minus sigma 2 whole square is equal to 2 sigma y square. Now see how I remember this formula, because there is some cyclic thing is there. That means you make two pair, square them. Sigma 1 minus sigma 1 whole square, sigma 2 minus sigma 3 whole square, the sigma 3 minus sigma 1 whole square is equal to 2 sigma y square. It has to be other side, there should be 2 sigma y square. If you get any doubt, you say that in uniaxial load case, this formula should match. So in uniaxial load case, I have sigma 1 is equal to sigma y, other things are 0, so if I put both the sides will match. So that is why this, so anyway, that formula is there. So now I have 2 sigma y square. So this side it becomes 2 sigma square and this becomes 150. So 150 is equal to 150. So that means yielding starts when sigma 1 and sigma 2 is equal to sigma 50 megapascal. Now this thing is basically as per formula. That means I have to remember this formula, sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3, the bracket close, whole square, sigma 3 minus sigma 1 whole square is equal to 2 sigma y square. But I can do the same problem by another concept. If I don't know the formula, I know that this is isotropic material and it is metal. So hydrostatic stress will not have any effect on that. So I impose on this minus sigma p minus 150 megapascal in all directions. Okay, that means sigma 1 is minus 150, sigma 2 is minus 150, sigma 3 minus 150. So this minus 150 will cancel. That means then sigma 1 side it will become 0, sigma 2 will become 0, and sigma 3 is equal to minus 150 will remain. Okay, so that means it will, so basically the yielding will start when it will become 150, because then it is a pure compression. Only 150 is there, pure compression 150. So that means answer is 150 there. So it should be basically 150 here also. That is how. So that means balanced biaxial, that if you apply sigma 1 and sigma 2 in both the direction, it is equivalent to that situation in which you apply one compression in the third direction. Both the things are similar, because in between only hydrostatic stress is there. So like that, based on the concepts, it is this one, based on these concepts, it can be done. Okay. So this question was also very nice. And I think that maybe 2-3 minutes are there. I just moved that. This one also, let us say that here, where is that thing? Yes. So this question also you just see the gate. In the gate, this type of question is very common. Merchant's first solution provides 2 phi plus beta minus alpha is equal to 90 degree. Now see, I have already given a formula. Is it not? So it depends from examiner to examiner. If you can, we can't say that sometimes this question may be asked also, but you know that sometimes the examiner will not test your memory. He will give the formula that this is this one. But see, if shear angle phi is 35 degree, rake angle is 5 degree, then the Coulomb's coefficient of friction is this. So you have to put in this thing and obtain beta. Now beta is the angle, so you should know that tan beta is equal to coefficient of friction. So this much work has to be done. Okay, now just see the thrust force in an orthogonal machining is 450 Newton and cutting force is 700 Newton. The friction force between the tool and chip is 586 Newton. The normal force at the tool chip interface is what? So two force components have been given on one side, that means on the side of the tool, and the other have been given on the other side of the chip. So both the things resultant forces should be equal. That means 450 square plus 700 square will be equal to 586 square plus normal force square. So like that you can find out that this will be the component. Okay. So don't have to use any formula here and do that. Oblique cutting process inclination angle is this, effective rake angle is this. Usually in paper that you know it is better that if you can prepare well, but there is a high probability that there will not be questions based on the three-dimensional in that type of exam. Okay, but they may have these basic questions are very common. Say in an orthogonal cutting with zero rake angle tool, the resultant machining force is 500 and thrust force is 300. So you can show that it is orthogonal, so thrust force is 300, resultant is 500, so that means cutting force is 400 and cutting speed is 6 meter per minute. So the cutting ratio is 0.5. Power dissipation due to friction. So many things have been asked roundabout way. First you have to find out total power. So total power will be cutting force into cutting speed. Cutting speed is also given in meter per minute. So you have to convert in meter per second, that divided by 60. So that means 1 meter per second. And this will be 400. So 400 watt basically. But the cutting ratio is 0.5. So that means cutting ratio is 0.5. Okay, now you have to find out power dissipation due to this one. So chip velocity will be half that. Cutting speed is 1 meter per minute. That means that is cutting ratio is 0.5. So 1 meter into 0.5. So 0.5 meter per second. And the thrust force is 300, but rake angle is 0. So therefore what happens that the thrust force becomes not the thrust force. Okay. Thrust force is basically thrust force becomes the friction force. Okay. So 300 into 0.5. That means it becomes 150 watt. So like that. So all these concepts should be clear that how it becomes like this. Okay. And this is equal to that one. So I think that we have explained that in this subject of exam, how many percentage marks for the problem in NPTEL. That means, okay, yes, sir, we will have about that, maybe about 60% maybe numerical type problem, 40% based on the conceptual theory type thing. But it is, but many questions may be from assignment also as it is. Okay. So assignment should be done. Okay. Assignment will be at least 25%, maybe ditto, 25% will be similar type of thing, and conceptual one. So this time compared to the previous one, this time slightly more theoretical type of questions, so that it becomes even more easier to score marks for the students actually compared to previous year's question paper. Okay, so this is this thing. So I think that we have spent. Rekha, should we close the session now? Hello. Yes, 1 hour complete, na? Okay. So I think the question also that one person has asked in detail the question, and I have answered all the questions in chat. He has been telling that, okay. So he has understood, and I have summarized. Other people can see the video, then they can know the practical type of things. Okay, that yeah, what this one. Okay, and pattern of the exam also has been told, which is anyway has been also told by the IIT Madras also. No? Okay, yeah. So fine. No? Okay. So I am logging out now. Okay. Should I leave the meeting? Yeah. Okay. Yes, fine. Okay, fine.